Hey there, 20-1s. Let's do some more factors, factoring and fraction work. Multiplying rationals last day, and today we're going to do dividing rational expressions. Not a big leap in what we're doing, small little change, but practice with this. So very quickly, let's just quickly review dividing rationals or fractions. Remember, if we have fractions that are being divided, we don't actually divide fractions. What do we want to do? We want to multiply by the reciprocal. So that's what we need to do. Our first rational stays as is, but here's the big changes. Division becomes multiplication. And the second fraction or rational reciprocates, flips. Numerator and denominator change position. So AB divided by CD now becomes AB times D over C. So it's one quick little step going back to junior high, and then what's great is now we multiply just like we talked about yesterday. So let's take a look at examples. Let's see what it's all about. Very quickly, just with the numbers, what are we going to do with 9/8 divided by 15/12? Well, the first thing is we want to become multiplication. 9/8 doesn't change, but we are going to multiply by the reciprocal, which is 12/15. 9 times 12, 8 times 15. Yeah, you could do it. You could even do it without a calculator, but reduce, cancel first. Like we talked about, one numerator, one denominator at a time, as long as it is multiplication. Never cancel when dividing. We're going to cancel now that we're multiplying. 9 over 8, 12 over 15, all kinds of different possibilities to start. I'm going to start with the 8 and the 12. Common factor of 4. 8 divided by 4 is a 2. 12 divided by 4 is a 3. There's my first step. Now I need another numerator denominator, all kinds of choices. I'm going to take my 3 and my 15 and reduce by 3. 3 divided by 3 is 1. 15 divided by 3 is 5. Is there any other canceling? At this point, all we have left in the numerator is a 9. All we have left in the denominator is 2 times 5, which is 10. So there's our final quotient. 9/8 divided by 15/12 is 9/10. That's division. Multiply and reciprocate your second rational, and then all you have is multiplication. So, rational expressions. Looks big and ugly. Lots of little steps, lots of room for errors. But if you've done the precursor work, shouldn't be too bad. Factor, all numerators and denominators. Here we go. X squared minus 4. X squared minus 4 is a difference of squares. X plus 2, X minus 2. There we go. X squared minus 4X. There we have a common factor of X that needs to be factored out. X times X minus 4 is what it becomes. Now I'm still going to keep it as division, and we'll talk why in a couple minutes. But at that point, X squared plus X minus 6, what do we have there? We have a simple trinomial, multiply to negative 6, add to 1. Well, that's going to be X minus, 2, and an X plus 3. There's your combination for the negative 6 and the positive 1. And the last part of our rational expression, the division, X squared plus 1X minus 20, multiply to negative 20, add to 1. In that case, we now have X minus 4 and an X plus 5, because negative 4 and 5 multiplies to negative 20, but adds to 1. Now, I'm going to jump down actually to our fifth step, this idea of NPVs. As I talked about last lesson, an NPV is for any point in a question when you could create a 0 in the denominator, which we don't want. So our NPVs at this point, because now I have fraction form, easy to identify my factors and identify what values of x make denominators of 0. Well, if x itself is a 0, I'll end up with a 0 in that first rational. So x can't be 0. That's an NPV. If this x minus 4 equals 0, that would be bad, and that's going to happen if x is a positive 4. So 4 is another NPV. Well, there's x minus 4 again, same thing, so I'm going to leave it. We already have that 4 in our NPV. And then if x plus 5 equals 0, that would be a bad thing, and that'll happen if x is negative 5. We need to list NPVs for all steps in the rational process. Because anytime I get a denominator of 0, the question implodes, not just in a final answer. At this point, it's division. I cannot cancel. So my second step is to reciprocate and convert to multiplying. So I still have x minus 2, x plus 2 over x times x minus 4. And I'm multiplying that. But now I'm multiplying, so I need to reciprocate my second rational. I now have x minus 4 times x plus 5 in my numerator, and I now have x minus 2 times x plus 3 in my denominator. Now that it's a multiplication question, now I can cancel common factors. What are my common factors? X minus 4 and an x minus 4. The binomial is a factor. I have to cancel the entire binomial. X minus 2 are common factors. Do I have any other common factors there? I don't believe I do. So now I need to multiply what's there. But please understand step 4, where it says to multiply but leave as factors. I now have in my numerator x plus 2 times x plus 5. I don't need to expand that. This is the acceptable form for my solution. Each step, I can leave it in the final step as the factor. And in my denominator, what am I left with? I'm left with an x times x plus 3. Almost finished. The last bit is we didn't check for NPVs in this step here. Well, we dealt with the x and the x plus 4, but if x minus 2 is 0, that's bad, which would mean x was 2. If x plus 3 was a 0, that would be bad, and that would occur if x is negative 3. So our initial question, the x squared minus 4 over x squared minus 4x divided by x squared plus x minus 6 over x squared plus x minus 20, there's our final value. And that is acceptable as long as x does not equal 0, 4, negative 5, 2, or negative 3. There's the division process. So let's take a look at a couple more. Here we go. Now this time we have c squared minus 6c minus 7 over c squared minus 49 divided by the c squared plus 8c plus 7 over c squared plus 7c. Just move it up a bit, a little bit more space. So what we're looking at here, the steps, factor, all numerators and denominators. You might want to stop the video, give it a try. Otherwise, follow along one more time. C squared minus 6c minus 7. Factor it. We have a simple trinomial. We end up with c minus 7 times c plus 1 over difference of squares, c plus 7 times c minus 7, divided by simple trinomial, c plus 7 and a c plus 1 over that c squared plus 7c, factor out a c, leaves us with c times c plus 7. I'm going to list my NPVs at this point for this first step. X, the NPVs occur, well, it's not an X, NPVs occur when C is equal to. Well, if that's a 0, that's because C is -7. If that's 0, that's because C is +7. So positive, -7 is one set here. We don't want C to be 0. And again, here we don't want C plus 7 to be 0 or C to be -7, which we've already identified. No need to identify again. So now we reciprocate. C minus 7 times C plus 1 over C plus 7 over, or times C minus 7. Multiply is what we now have, and we reciprocate. C over C plus 7, C plus 7 times C plus 1. There's the reciprocate and multiply, and now because it's multiplying, we can cancel. Cancel common factors. C minus 7, C minus 7. C plus 7, C plus 7. C plus 1, C plus 1. I cannot cancel these C's because C plus 7 is the entire factor. It's a binomial. I cannot cancel part of a binomial with the monomial. So what am I left with in my numerator? C. What am I left with in my denominator? All I have left is a C plus 7. So there, need those equal signs. Mentioned it last lesson, I keep forgetting. C over C plus 7. And what are the NPVs? Well, we've already dealt with those two. Can't have C plus 7 equal to 0, but we have the -7. Can't have C plus 1 equal to 0, so C cannot be -1. There's my NPVs. C over C plus 7 is my answer or my quotient for the original question, as long as C isn't positive or -7, 0 or -1. There's the process. Same steps over and over. It's a matter of having the little skill sets that lead into it. So now we get to questions where it's multiplying and dividing combined. It's really not a lot different. There's not a lot new steps. It's just you have to pick and choose for your reciprocate and convert division to multiplying. Obviously, not everything's going to be reciprocated. So here we go. First thing we have to do, as always, is we need to factor. So again, you might want to turn off the video, give it a try on your own, see what you come up with. Here we go. So 2m squared minus 7m minus 15. If you do decomp, you end up with 2m plus 3. This will be equal to, all this will equal times m minus 5 over, here we have GCF, factor out a 2m, and we get m minus 5. Divided by 4m squared minus 9 is a difference of squares. We're left with 2m minus 3 times 2m plus 3 over 6. Nothing happens there. And we're multiplying that by 3 minus 2m, which is over 1. So if I can put it into fraction form just for consistency. So we factored all numerators and denominators. Reciprocate, make multiplying. That's only the division here. So that means the 2m plus 3 times m minus 5 isn't going to change. 2m times m minus 5 isn't going to change. But now we need to reciprocate. 6 is up on top. The 2m minus 3 and the 2m plus 3 are now in the denominator because we've reciprocated. And our last bit times 3 minus 2m. That doesn't change because it's multiplying. I like to put the 3 minus 2m into brackets so I remember that that's the factor. I have to cancel all or nothing with those. So now everything is multiplying. I'm going to look at my NPVs. And again, NPVs for every step of the way. So here, if that equaled 0, it's because m equaled 0. Here, this would equal 0 if m equaled 5. Here, there's nothing. But NPVs for all steps in the process. We've already dealt with those two. When will 2m minus 3 have a value of 0? Well, if it helps, 2m minus 3 will equal 0. Isolate the m, add 3 to both sides, divide by 2, m equals 3 halves. And 2m plus 3, if it equals 0, same idea, it'll be because we have a negative 3 halves. So positive negative 3 halves is another set of NPVs. From there, and of course 1, there is no NPV because there's no m value, no variable. Dealt with the NPVs, everything's multiplying, cancel. So 2m plus 3 and a 2m plus 3. M minus 5 and an M minus 5. Now, something that I hope you recognize, here we have a 2M minus 3 and a 3 minus 2M. Almost the right stuff. 2M positive negative 3. Negative 2M positive 3. How do I make it so I have the right things? If I factor out a negative 1 here. Factor out a negative 1, I then have negative 3 plus 2m. We looked at this with the simplifying rationals process. Because I factor out a negative 1, well, now I have the 2m minus 3 and the 2m minus 3. Those will cancel. Last bit you have to be careful of. 2m and 6. This is a monomial. This is a monomial. I can now, because it's one term, I can reduce that 2 to a 1 and reduce the 6 by 2 to be 3. Because 2m is a single term, it can be divided by 2, which I did. 6 can be divided by 2, which I did. So watch for those little things. At that point, now we look at what we're left with. What do we have in our numerator? Whole bunch of stuff canceled, but we're left with a 3 times negative 1, so we get negative 3. What are we left with in the denominator when we multiply? Well, we still have the m times 1, and m times 1 is m. So the answer to our question is negative 3m as long as m does not equal 0, 5, or positive or negative 3 halves. Lots of little steps, factoring, canceling, and being careful. That's what this is all about. Last one, page 8. Give this one a try, and then we'll talk as a group. Pause the video, see what you come up with. All right, here we go. As always, factor numerators, denominators. Factor out a 3. We're going to equal 3 times x plus 4 over 3x squared minus 5x minus 12. Decomposition. That's a complex trinomial. Decomposition. If you show your steps, you should end up with 3x plus 4 times x minus 3. We're dividing that by 12. 3x plus 4 doesn't factor, just stays as is. Times 2x minus 6, factor out a 2. And x plus 4 doesn't factor. So we've done all our factoring. Here I am identifying my NPVs at this point. Our x for NPVs occur when x is equal to, if this equals 0, 3x plus 4 equals 0, that means x is negative 4/3. If x minus 3 equals 0, that's because x equaled 3. 3x plus 4, well, we've already done that once, so we have the negative 4/3. X plus 4 equals 0 if x equals negative 4. So we've dealt with NPVs, we factored, now we have to reciprocate and convert to multiplying. So this will equal our 3 times x plus 4 over 3x plus 4 times x minus 3 doesn't change. However, division is going to become multiplying, so we have to reciprocate. Our multiplication doesn't change. We're happy with multiplying, so we're going to multiply and we keep it as is. Double check your NPVs. The 3x plus 4 and x minus 3 hasn't changed. It's still there. 12 doesn't have an NPV because it's 12. There's no variable that's going to affect it. And x plus 4 hasn't changed. So we have the same NPVs. At this point now it's all multiplying. Let's cancel. If we're going to cancel, we have a 3x plus 4 and a 3x plus 4. We have an x plus 4 and an x plus 4. We have an x minus 3 and an x minus 3. What else do we have? We then have, and I'm going to change colors because it's hard to see, we have a 3 and a 2 and a 12. Well, technically, we can start to cancel. 3 and 12 will reduce by 3. Leaves us with a 1. 12 divided by 3 is 4. We now have a 2 and a 4. Those will cancel by 2. Leaves us with a 1 and a 2. So our answer is 1/2. This big multiplying dividing question is equal to 1/2. And when does it equal 1/2? It equals 1/2 as long as our x's don't equal -4/3, 3, or -4. Lots of little steps. Nothing's new in there. Factoring, multiplying fractions, dividing fractions. It's just a matter of putting it all together. Textbook, page 327, 4, 8, 14, 15, 16, 18. And then supplemental handouts. This is in the worksheet section. If you didn't find it last lesson, it's in the worksheet section of the Google Classroom. Please, section 6.2, number 6, a little extra practice, because this is all about practice. That's what you need to do. Ladies and gentlemen, have fun with it. We'll talk to you next lesson.